Alright, so in the last video we talked about the rational roots. We talked about the fundamental theorem of algebra. Remember, third degree, there are 3 total roots. These are the type roots we might have. And remember your rational root theorem, you would take the factors of your constant, put it over the factors of the leading coefficient, and those were a list of possibilities for roots, and then we tested the roots here, and then we could find the rest of the roots using the quadratic formula. So in this video we're going to go a little bit further with that. Okay, in this one we're going to find all of the roots, but I'm going to show you a way to narrow things down a little bit more quickly using a graphing calculator. Something you need to remember is your college professors may or may not allow you to use a graphing calculator, so you need to know how to do it without. So we've done one without, now we'll do one with a graphing calculator. And then at some point we will do one totally without. But we've got to learn a few more things first. So for this one, the first thing you need to know is how many total roots. Because this is a 4th degree, we have 4 total roots. Alright, so now step 1, it says to use the rational root theorem to find the possible rational roots. So for step 1, we're going to put the factors of our constant on the top. So we've got the factors of 18, and that's going to go over the factors of the leading coefficient, which is 1. So the factors of 18, that's going to be plus or minus 1 and plus or minus 18 plus or minus 2. Let me fix that, I got ahead of myself. Alright, so plus or minus 2 and plus or minus 9. You've also got plus or minus 3 and plus or minus 6. Your factors of 1 are simply plus or minus 1. So your rational roots, if I take each of the ones on top, put it over the one that's on the bottom, this is what I'm going to get for my rational, or my possible rational roots. So now, in the last example, we just started testing these, just picking the ones we liked and testing them with synthetic division to see if they gave me a remainder of 0. If they didn't, we marked it out and we went on to the next one. Well, that's a whole lot of time and effort and a lot of work. So what I want to show you now is how to simplify that a little bit using your graphing calculator. So if we grab our calculator here, go to y equals and type in your equation. Let's double check it. X to the 4th minus 4x to the 3rd minus 16x squared plus 21x plus 18. Alright, so let's go ahead and graph it. Okay, and looking at the graph, I can see that it touches the x-axis 4 times, so all of my roots are going to be real roots, no imaginary ones this time. I've got one that looks like it touches it here at -3. Well, -3 is in my list of possible rational roots. But then I've got another one over here, 1, 2, 3, 4, 5, +6, that is also in my list. So those rational roots, I can verify those possibilities from looking at the graph. What I don't know are what these here in the middle of my graph are. So let's go back and let's test the ones we could see in our calculator using synthetic division. So we could see -3 from the graph. So we're going to put -3 in the box. And here's my coefficients. I didn't need any placeholders this time. Okay, doing my synthetic division. And yes, I do get a remainder of 0, so I have been able to verify this is one of my roots. But I also was able to see that 6 was a root on the graph. So let me show you how to go from there. Because at this point, since I started out with an x to the 4th, this is going to be x to the 3rd, x squared, and an x. I can't find the other roots from here because this is not factorable. Okay, this is a factor of this. Remember, it's also called our depressed polynomial. So your second step would be to put your other root you could see from the calculator in the box and use this depressed polynomial to get your coefficients. So do your synthetic division here. Get a remainder of 0. So once again, I have verified mathematically that 6 is a root. And now I've gone from an x to the 3rd down to x squared minus x minus 1. Once we are down to a quadratic equation, I can go to step 3, okay, and I skipped right in step 2. This was step 2 where I tested the possibilities with synthetic division. So step 3, I'm going to take x squared minus x minus 1 equals 0, and I'm going to solve by factoring if it's factorable, or completing the square, or using the quadratic formula. So I'm going to do the quadratic formula for this. Okay, so when I plug this in, I'm going to have negative b, so that is a negative, -1, plus or minus the square root of b squared minus 4 times a times c, and all of that goes over 2 times a. So I end up with 1 plus or minus the square root of 1 plus 4 over 2. So that's 1 plus or minus the square root of 5 over 2. I can't simplify it any further. I end up with 2 roots there. So if we look, I've got 2 roots, 1 more, and 1 more. That is all 4. So my solutions, or all of the roots, are going to be x equals -3, +6, and 1 plus or minus the square root of 5 over 2. Okay, so that's how you can use what we've been working with our graphing calculators for. That's how you can use it to narrow things down a little bit. Okay, remember I told you that some college professors will not let you use a graphing calculator, so you have to have a way to do it without. Well, there is another tool we have that can help us narrow down which possibilities to try, and we're going to cover it in the next video. It will be for Descartes' rule of signs.